Welcome to another video. We're going to look at cases with quadratic denominator that cannot be factorized. It's a general rule that we have to comply with whenever we want to resolve a fraction that has quadratic denominator that cannot be factorized. If we have, say, ax plus b, or let me just say 2x plus 3, and we have x minus a and x squared minus x minus 1 x squared minus 3x minus 3. Let's assume that this part of the denominator cannot be factorized further. So we have two factors. So we're going to represent this by we say let it be identical to this factor. We have a x minus 1, and then this part of it will have a bx plus c over x squared minus 3x minus 3. So what is the general form of resolving fractions into parts, especially the ones that have the denominator part that cannot be factorized in the general form? So the highest power of x here is less than the highest power of x as the power here. So the examples we're going to take further will show how to go about the simplification, but this is the general form when the case that the quadratic denominator cannot be factorized. So let's take this example solution. So it's a net 3 identical to u over x plus bx plus c over x squared minus 5x plus 2. So if you try to simplify this part, which is the quadratic expression part, and you discover that it's not factorizable, then you just say multiply through by x minus 1 x squared minus 5x plus 2. I need to say that the reason why we're using this general form for this resolution is because you discover that this quadratic part is not factorizable. That is why if a quadratic part that has this factor that is quadratic has bx plus c, but if it's factorizable, you factorize, then it's going to have b over the other factor plus c over a. So in case you want to get to know how to resolve the quadratic part that is factorizable, check the other video where I treat that. But in this video we are looking at if one of the factors, which is a denominator, is non-factorizable. This is the general form bx plus c. So you multiply through by this, and you're going to have 3 equals to x squared minus 5x plus 2 plus bx plus c over x minus 1. Okay, so next thing is that we are going to expand. So this is equals to 2 is equals to x squared plus 2 minus 5x plus 2 plus 2bx x minus 1 plus cx minus 1. So if we expand further to result to x squared minus 5x plus 2 plus Okay. For now, okay, let's leave it like this for now. So we're leaving it like this now for now because we discovered that in this form both c and bx have x minus 1 in common. So this will help us to get the value of a if we make x equals to 1 in that way. If x is 1, then this becomes 1 minus 1 0, 1 minus 1 0. So 0 times c is 0, 0 times bx, which here also be 1, which is b, 0 times b is 0. So that's where we have eliminated b and c, so leaving only a as a variable to work with. To get a, we need to put x equals to 1, so 3 is equals to a 1 squared minus 5 1 plus 2. This is equals to 3 is equals to a 1 minus 5 plus 2. So this will give us minus 2, so minus 2a. So a is equals to minus 3 over 2. That's the value of a. Now we're going to get b, and c. We're going to expand that's expand the equation on the right hand side, which is this part. So we're going to have 2 is equals to a x squared minus 5x minus 5a x plus 2a. bx times x will give us bx squared minus bx plus cx minus c. So 3 is a x squared plus bx squared. Then bring factors in x together, minus 5ax minus bx, then plus 2a. Okay, we have plus cx, and then we have plus 2a minus c. So 2 is equals to x squared a plus b, then minus, so we have plus x minus 5a minus b plus c, and then plus 2a minus c. Okay, so now the next thing is for us to do, we want to get, we know the value of a, so we want to get the value of b. So we can get the value of b from here. So which means we're going to equate coefficients in x squared. Remember that this left hand side of the equation does not have coefficients in x squared, so that means it's 0. So we say equating times or equating coefficients in x squared. Coefficients in x squared, we're going to have a plus b is equals to 0. So it doesn't give us, but e is equals to minus 3 over 2. So put this place of a is equals minus 3 over 2 plus b is equals to 0. So correct like terms, this will cross over to the size of b is equals to 0 plus 3 over 2. So b is equals to 3 over 2. Okay, so now we have the value of b and e. Okay, so we could use this formula. If we use this part, that means we're going to equate coefficients in x. So this part doesn't have coefficient x, so it's still going to be 0. So if you put in a value of a and b and then solve for c, we could get the value of c from here. However, I want to use this part, which is constant. So I'm going to equate constants. Equating constants is going to be, so this is a constant and this is a constant. So 2a minus c is equals to 3, but a is equals to minus 3 over 2. So 2 minus 3 over 2 minus c is equals to 3. This 2 cancel this 2. So it's over there. Minus 3 minus c is equals to 3. So minus c is equals to 3 plus 3. Minus c is equals to 6. So c is equals to minus 6. Therefore a is equals to minus 3 over 2. B is equals to 3 over 2. And c is equals to minus 6. Plus 3 over x minus 1 x squared minus 5 x plus 2 is identical or equals to. Remember, the proposition was let the fraction we are given to resolve is to be equals to a over x minus 1 plus bx plus 2. So these a, b, c are variables that we solve to get their values. Now that we've gotten the values, we need to substitute the values in place of each of the variables, and we need to do that carefully. So for a is minus 3 over 2. So this will give us minus 3 over 2 x minus 1. Okay, plus. So now bx in this part of the fraction is the numerator bx plus c. So b is 3 over 2, which gives us 3 over 2x, and our c is minus 6 plus minus 6 over x squared minus 5x plus 2. So this will give us minus 3 over 2x minus 1. So we simplify this part, this denominator, so we simplify the denominator. So this is like how it sounds like 3 over 2x plus times minus is minus 6 over 1. So the denominator is equals to, so the LCM is 2. 2 into 2, 1. 1 times 3, that will give us 3x minus 2 into 1 is 2. 2 times 6 is 12. So this will give us plus 3x minus 12 over. So we bring the 2, which is the denominator, down to this side. So it becomes 2 over x squared minus 5x plus 2. Okay, so that's what we're going to have. Now finally, since this part is positive and this part is negative, we can rewrite it by saying that okay, let's not compare to therefore can write it by saying that therefore 3 over x minus 1 x squared minus 5x plus 2 is equals to or identical to, we can start with this part, 2x minus 12 over 2 x squared minus 5x plus 2 minus 3 over 2 x minus 1. Sure. First of all, attempt to factorize this part, and if you discover that it's not factorizable, which in this case it is not, then you resolve it through the general form that expressions of this nature are factorial resolved into the various parts, which is x plus 3 over x squared plus 2. So the first factor, which is not a quadratic expression in nature, will have the first part, which is x. So this part will be x e over x. Then the factor that has the denominator that is quadratic expression, we'll have this numerator bx plus c as the numerator over x squared plus 2. So this is the general form. Generally, the quadratic expression denominator will have this part as the numerator bx plus c, right? The part that is linear, which has the highest power as 1, we have e as the numerator. Then you multiply through. Multiplying through by x squared plus 2. Okay, so this will eliminate all of this, and here will be x plus 2 is equals to, this will eliminate this, so this part will be left e over x squared plus 2, then plus bx plus c multiply x. Okay, so this will give us x plus 2x plus 3 x squared plus 2 plus bx x plus c x. Okay, so generally this will give us bx squared, but I choose to leave it in this form because I want to get e, the value of e first. So which means if I put here or make x with 0, 0 times c will be 0, 0 times 0, which is 0 times 0 will give us 0, so which is practically c and b will be eliminated. So okay, let's go for that. So x plus 2 is equals to x squared plus 2 plus bx squared plus bx. Okay, so to get a root x equals to 0, so which means I'm trying to eliminate b and c. So if x is 0, 0 times c will be 0, 0 squared is 0, 0 times b is 0. So I'm going to have only 0 e to solve for. So x 0 plus 3 is equals to e 0 squared plus 2, which is 3 equals to e over 2. So 3 is equals to 2 e and e is equals to 3 over 2. So now that the value of a is known, which is 3 over 2, we're going to get the value of b, and to do that we're going to equate. And so b is a coefficient of x squared, so we're going to equate coefficients in x squared. Equating coefficients in x squared will give us, so on this side of our equation we don't have coefficient in x squared, rather we have coefficient in x and a constant 10. So which means the coefficient in x squared on this side is 0. So e x squared, so e x squared as e plus b is equals to 0. When we say both, e is equals to 3 over 2. So 3 over 2 plus b is equals to 0. So we collect like terms, b is equals to 0 minus 3 over 2, and b is equals to minus 3 over 2. So that's value of b. Now, to look for c, c is this coefficient in x. So we're going to equate coefficients in x, which is this and this. So equating coefficients in x, we have x is equals to cx. So x here 1, x here 1. 1 times c is c, and 1 is equals to c. So therefore e is equals to 3 over 2, b is equals to minus 3 over 2, and c is equals to 1. So we say thus or substituting values of P, B, and C into our initial proposition. So we said initially that let x plus 3 over x squared plus 2 equals to e over x b x plus 6, where e, b, and c are variables which we've gotten their values here. So we're going to put each of the values into this general equation form. So x plus 2 over x over x squared plus 2 is equals to, so our e is 3 over 2. This is 3 over 2x plus, for b is minus 3 over 2x plus c, which is 1 over x squared plus 2. So let's simplify this part. To simplify that part, we're going to have y minus 3x plus 1 over 2 over 1. So this is 2 minus 3x plus 2. So, okay, so this is just equals to 3 over 2x plus minus 3x plus 2 over 2 over x squared plus 2. So this gives us 3 over 2x plus, okay, since we cannot have something like forms like this because of the sign, this will give us minus 3x plus 2 over 2x squared plus 2. Because this sign is not a general sign that affects the whole of the expression, it's only this part of the expression that's affecting. So we're going to write this first, so that doesn't affect the plus sign here. This plus 3 over 2x plus, bring it plus 2, then minus 2x over 2x squared plus 2. Resolve x squared plus 4x plus 1 over x is about 3 plus 3x squared plus 4x plus 2 into partial fractions. The rule that we must obey anytime we need to, or we have to resolve expressions like this into partial fractions is that strictly the power or the highest power in the denominator must be less than that of the power in the numerator. In this case, x to the power 3 is higher than x to the power 2. So we need to simplify it in such a way that this becomes less than the power here. So already this is a polynomial. So we're going to find the factors of this polynomial and then divide it by the factors to get the other factors. We're supposed to have 2 or 3 factors from this expression. So we're going to get, first of all, the first factor, and that's first factor which is in the form of x minus e. That first factor, we're going to, once we get it, we are going to divide this whole fact expression to get the other 2 factors if it's going to be factorizable. But if it's not going to be factorizable, we're going to have just this and the other factor, which is going to be x, let's say e x squared plus bx plus c in this form. If this final if this is not going to be factorizable, then we're going to do it like this. So this is what I mean. Now for us to get that, let me write solution. So let's simplify this part. Let's call this f x equals x to the power 3 plus 3x squared plus 4x plus 2. So let's get the factor, one of the factors of this expression. And to do that, we're going to use a try and error method. So we're going to try x plus 1. Let's try x plus 1. So if you try x plus 1, it means if you try x plus 1 as a factor, it means if we equate it to 0, it will be x equals to minus 1. So which means that in this expression we can say let x be minus 1. So let's try x minus 1. So this means that anywhere we see x in this expression, we put minus 1. If it equates it to 0, if our final answer here is 0, that means x plus 1 is a factor of this expression. But if it's not equal to 0, it implies that x plus 1 is not a factor of this expression. So we're not going to take it. So let's see. Minus 1 is power 3 plus 3 minus 1 squared plus 4 minus 1 plus 2. Okay. So let's see. Minus 1 to the power 3 is minus 1. Minus 1 to the power 2 is 1. 1 times 3 is plus 3. Plus 4 times minus 1 is minus 4 plus 2. So let's do our addition and subtraction and see if we're going to arrive at 0 or if it's going to be equal to 0. Minus 1 plus 3 will give us 2. 2 plus 2 is 4. 4 minus 4 is 0. So that means that x plus 1 is a factor of this expression. So from our trial and error method, we discovered that x plus 1, therefore x plus 1 is a factor. It's a factor of x raised to the power 3 plus 3x squared plus 4x plus 2. Okay, but so for us to go further, we're going to divide this expression by this factor so that we can get the other factors. We're going to, this will give us x plus 1, so x raised to the power 3 plus 3x squared plus 4x plus 2. So x into x raised to the power 3 is equals to x raised to the power 2. So x raised to the power 2 times x will give us x raised to the power 3. X raised to the power 2 times plus 1 will give us plus x squared. So when you subtract, this will x raised to the power 3 minus x raised to 3 is 0. Minus x plus is minus. So 3x squared minus x squared will give us 2x squared. So you bring down your 4x. Okay. So x into 2x squared will give us x, 2x plus 2x, 2x times x. Just like as in 2x squared, we all have is 2x squared divided by x. X will cancel x, will be left with 2x. So put here, then use this 2x to multiply x first, then use the 2x to multiply 1, and then put them here. That's what we do. So 2x times x will give us 2x squared. 2x times plus 1 will give us plus 2x. We subtract. This will give us 0. 4x minus 2x will give us 2x plus, bring down your 2. So x over 2x is just like 2x over 2. Sorry, 2x over x. So this x will cancel. So we're going to be left with 2 plus 2. So 2 times x gives us 2x. And 2 times 2 will give us plus 2. When you subtract, we're going to have 0. Okay. So therefore, so this simplifies. This means that this whole expression simplifies to this form: x squared plus 2x plus 2. So the next thing is to verify if this expression is an expression that can be factorized. So if we come here, we multiply this together, this equals 2x squared. So which means we're going to look for two factors. So let's see if we have here x squared plus 2x plus 2. So if you multiply this together, we have plus 2x squared, two factors of x. of 2x squared. When multiplied, will give us 2x squared, and when added, will give us 2x. So factors of 2x will give us 2x plus 2, minus 2x times minus x. So minus x minus equals plus 2x times x will give us 2x squared. But minus 2x minus x equals to minus 3x. So it's not giving us what we have here. Okay. Another one is factor. So you can see that this expression cannot be factorized. So since it cannot be factorized into factors, that okay, automatically these two becomes the factors of this expression. So this means our expression here is now in this form. So we have here x squared plus 4x plus 1 is over x raised to the power 3 plus 3x squared plus 4x plus 2 is equals to x squared plus 4x plus 1 over x minus 1 and x squared plus 2x plus 2. So since this is not in this form, and we have to resolve this into partial fractions, so we say let x squared plus 4x plus 1 over x minus 1 x squared plus 2x plus 2 be equals to e x minus 1 plus bx plus c equals to x squared plus 2x plus 2. So the next thing is to multiply through. Multiplying through by x minus 1 x squared plus 2x plus 2. We're going to have x squared plus 4x plus 1 equals to e x squared plus 2x plus 2 plus bx plus c over x minus 1. So this is x squared plus 4x plus 1 is equals to e x squared plus 2x plus 2 plus bx x minus 1 plus c x minus 1. So because in this form we can easily eliminate bx and c. So we can easily eliminate b and c since both of them have x minus 1 x minus 1 common. So in that way we can get the value of e first. So to get e, put x equals to, since e is minus 1, put x equals to 1. So if x is equals to 1, 1 minus x is 0, 1 minus x is 0, 0 times c is 0. So there is 0 and there is 1. 1 times b is 1, is b. B times 0 is 0, so b and c are eliminated. So x, so here 1 squared plus 4, 1 plus 1 is equals to 3, 1 squared plus 2, 1 plus 2. So this is 1 plus 4 plus 1 is equals to 3, 1 plus 2 plus 2. 2 plus 2, 4 plus 1, 5. 4 plus 6. So it's equals to 6 on this side, plus a 5 on this side. So a is equals to 6 over 5. A is 6 over 5. So get b. So bx x minus 1. So that means we are going to expand. Our factor is x plus 1 And why do I have x minus 1 here? So x plus 1 is a factor, so I think I need to correct this. This is x plus 1, x plus 1, x plus 1 plus 1 plus 1. So I'm going to start again from here. So I'm putting x, put x. Okay, so put x equals to minus 1. So that, if I look at the attempts to make here 0, make here 0. So since it has plus 1, minus 1 plus 1, we make it 0. So to get e, and in order to eliminate b and c, put x equals to minus 1, or make x equal to minus 1. So anywhere there is x, just put minus 1 in place of it. So here we've got minus 1. Minus 1 plus 1 is 0. 0 times, same thing here is minus b. So 0 times minus b will be 0. B is eliminated, same thing with c. C is eliminated. So this becomes minus 1 squared plus 4 minus 1 plus 1 is equals to e. Minus 1 squared plus 2 minus 1 plus 2. So it becomes 1 minus 4 plus 1. Okay. And here e is 1 minus 2 plus 2. So this becomes here plus 4 minus 4, 1 plus 1. So this is, so here minus 2 plus e is 0, 1 e. So minus 2 is equals to e. So e is equals to minus 2. So now that we know the value of e to be minus 2, let me just see. To get, okay, so to get b and c, I'm going to get b and c. I'm going to expand that's like this. I'm going to expand to get b and c, expand out. This means I'm going to expand the equation on the right hand side, this part, so that I can have coefficients in x squared and coefficients in x, and coefficients as a constant. So x squared plus 4x, x squared plus 4x plus 1 is equals to, so this equals to e x squared, e times 2x equals plus 2ax and plus 2e. Okay, so bx times x equals bx squared plus bx squared plus bx times 1 equals plus bx, then plus c times x equals plus cx plus c times plus 1 equals plus c. So this equals x squared plus 4x plus 1 is ax squared plus bx squared. Alright, then plus 2ax plus bx plus cx, then plus 2e plus c, x squared plus 4x plus 1 is equals to x squared plus e plus b, okay, plus x plus 2e plus b plus c and plus 2e plus c. So in this form, we can equate equation in x squared, we equate to this. Equation for in x, we equate to this part, and the constant term will equate to this part. So so to get, we know our e. So once we get c, we get the equating constant term equating constants, we have 2a plus c is equals to 1. So but a is equals to -2. So 2 minus 2 plus c is equals to 1. So this is -4 plus c is equals to 1. And c is equals to 1 plus 4, which is equals to 5. Then next is another button c. We equate terms in equating terms or equating terms in x. I have 2a plus b plus c is equals to 4. So both a is -2 and c is 5. So 2 minus 2 plus b plus c, which is 5, equals to 4. So -4 plus b plus 5 is equals to 4. So b plus 1 is equals to 4. B is equals to 4 minus 1. B is equals to 3. So therefore E is equals to -2. B is equals to 3. And C is equals to 5. So I come here, you see, plus x squared plus 4x plus 1 over x plus 1 x squared plus 2x plus 2 is equals to, so now we said let me get the first part to be e over x plus 1. So okay, yeah, so e over x plus 1. So our e is -2. So we say -2 over x plus 1 and plus bx. So our b is 3. So that will give us 3x. And what's our c? And c is 5 over x squared plus 2x plus 2. Okay, we can leave it like this. Yeah, that's the answer. Okay, solution. So let x squared plus x plus 4 equals to 1 minus x, and x is equal to plus 1 will be identical to e over the first factor minus x plus bx plus c over x raised to the power 2 plus 1. Okay, so multiplying 2 multiplying 2 by 1 minus x and x to the power 2 plus 1. We will have x squared plus x plus 4 is equals to e x squared plus 1 plus bx plus c will give us 1 minus x x squared plus x plus 4 plus e x is to the plus 1 plus bx minus x plus c 1 minus x. Okay. X squared plus x plus 4 equals to e x squared plus a times 1 gives us a dx times 1 gives us bx. Yes, gives us minus bx squared. Yeah, plus c times 1 gives us c minus cx. this is equals to x squared plus x plus 4 is equals to ax squared and bx minus bx squared. Then coefficients in x will give us plus bx plus bx and minus cx. And constants will give us plus e plus c plus e plus c. So x squared plus x squared plus x plus 4 is equals to x squared a minus b n plus x b minus c plus e plus c. So equating coefficients in x squared, we're going to have x squared is equals to x squared over a minus b. So this here 1, this here 1. 1 times this will give us a minus b equals to 1. Equation 1. Equating coefficients in x, which is this part. You have x b minus c equals to x. X is 1, x is 1. So b minus c is equals to 1. Equation 2. So equating constants. You have e plus c is equals to 4. Equation 3. So add equation 2 to equation 3. You have to get element c. So add equation 2 to 3. So we're going to have equation 2 is b minus c is equals to 1. And equation 3 is e plus c is equals to 4. So we're supposed to add. So if we had, this will give us b or a plus b. So this will mean c, a plus b will give us 1 as 5. So this will give us equation 4. So this is equation 4. We have a plus b, so let's see. Okay, so equation 1 has a minus b, so we're going to add equation 1 to equation 4. So this will give us equation 1 is a minus b equals to 1. Equation 4 is e plus b is equals to 5. So when we add, this will eliminate b. Minus b plus b is 0. A plus e is 2e. 1 plus 5 is 6. So e is equals to 6 divided by 2, which is equals to 3. The value of e is 3. Now, so if e is 3, in equation, okay, here we have e. Okay, so from equation 3, which is a plus c is equals to 4. A plus c is equals to 4. We already know that equation a is 3. So say both e is equals to 3, so 3 plus c is equals to 4, and c is equals to 4 minus 3, c is equals to 1. So if c is equals to 1, then let's look at where we can, from equation, okay, we can either use equation 2 because we have b, and look for the value of b here, or use equation 4 to get the value of b. So let's use equation 2. So from equation 2, b minus c is equals to 1. We say but b, we've not got the value of b, but c is equals to 1. So we say b minus c is equals to b minus 1 equals to 1. So b, when this crosses, right, comes plus So B is equals to 2. Therefore A is equals to 3 and B is equals to 2 and C is equals to 1. Hence, you can say hence x squared plus x plus 4 over 1 minus x and x squared plus 1 is equals to, remember we said let it be equal to a 1 minus x squared, our a is 3, is equals to 3 over 1 minus x plus, and this part bx, our b is 2, that's plus 2x, and c is 1 plus 1 over x squared plus 1. So if x plus p over this is identical to q over x minus 1 plus 2 over x minus 3, find the value of p plus q. Solution. So we say let x plus p over x minus 1, x minus 1 over x minus 3 be equal or identical to q over x minus 1 plus 2 x minus 3. So multiplying through by x minus 1, x minus 2. So this will give us x plus p equals to q x minus 3 plus 2x minus 1. So x plus p is equals to qx minus 3q plus 2x minus 2. So x plus p, so qx plus 2x, qx plus 2x, then minus 3q minus 2q minus 2. So x plus p is equals to x q plus 2 minus 3q is 2. So equating terms or coefficients, in x, we do have x cubed plus 2 equals to x, x is 1, x is 1. So q plus 2 is equals to 1, and q is equals to 1 minus 2. So q is equals to minus 1. Equating coefficients, constants, rather, equating constants, minus 3 q minus 2 equals to p. So minus, where q is equals to minus 1, minus 2 is equals to p. Minus 3 minus 1 is equals to 3 minus 2 equals to p. So p, 3 minus 2 is 1 equals to p, and p is equals to 1. So therefore p is equals to 1 and q is equals to minus 1. But the question says we should look for the value of p plus q. So p plus q is equals to 1 minus 1, which is equals to 0.